Fanshawe College has made a commitment to decrease the college's impact on the environment through updates to both physical spaces and academic curriculum. Compared to our 2013 baseline year, Fanshawe aims to reduce greenhouse gas emissions 30% by 2030 and 80% by 2050. Built in the 1990s, Kestrel Court Complex at Fanshawe College consists of 66 townhouses and provides accommodation to approximately 400 students. There was a huge opportunity to reduce energy consumption and greenhouse gas emission in the Kestrel Court residences. We developed a plan to trial solutions the London Home Builders Association had chosen to focus upon during their Local Energy Efficiency Partnerships Initiative. With an industry-driven plan focused on deep energy retrofits, the resulting proposal received funding support from Natural Resources Canada's Office of Energy R&D.
The overall strategy was first to address envelope measures like air sealing, insulation, and windows. This allowed us to right-size the HVAC equipment for the upgraded building shell. Then, to make everything work seamlessly and reliably, we had to set up the system's controls properly. We wanted to make sure the heat pump ran for as long as possible throughout the heating season and limited our reliance on our backup system. When setting up the thermostat and overall control strategy, you need to evaluate the switchover temperature where backup heating kicks in. In the heat pump world, there's what's known as the thermal balance point temperature. This is the outdoor temperature where the heat pump's output capacity matches the building's heating load. Above this outdoor temperature, the heat pump is able to fully meet the building's heating requirements. However, below this point, there's a need for backup heat to kick in. In the past few years, there have been advances in controls that can operate on what's called the economic balance point temperature. This takes into account utility costs for switchover, focusing on low operating cost. Enercan's Air Source Heat Pump Sizing and Selection Guide can help you calculate these two set points. There's three important options. First, if your goal is greenhouse gas savings, you should let the heat pump run as much as possible through the heating season, down to as low a temperature as possible. Second, if lower operating costs are the objective and the heat pump can't meet the load at low temperatures and there's backup heating from gas, consider the respective fuel costs to determine the economic switchover point. Finally, the strategy should be to let the heat pump work to as low a temperature as possible, then supplement with electric, shutting off the heat pump only when it's necessary. Leaving the default settings is never a good idea. It's important that the installer review all the settings and make proper adjustments to reflect the owner's objectives and ensure the equipment works as efficiently as possible. Heat pumps, together with appropriate control strategies, play a vital role in reducing our operating costs and our carbon footprint.
We've had more than 150 students involved in the scoping and design concept of this retrofit. We're proud of our students, and they are the future and the force multipliers to replicate and improve on this experience for other institutes across Canada.